When you're playing table tennis, you spin the ball. And when you spin the ball, you're applying a torque to it and causing it to rotate. And an important factor in that is the moment of inertia of the ball. Now, in fact, the moment of inertia in the ball we expect to be pretty small. You don't sense a tremendous resistance to rotation when you try to rotate a table tennis ball. But we're going to try to figure out the moment of inertia of the table tennis ball. And to assess our results, we can just say this going in. We expect the number to be quite small indeed. So to prepare, we'll just do this. We're asked to compute the moment of inertia of a table tennis ball about an axis that passes through its center. And we're told it's a thin spherical shell. Well, you know that if you've ever played table tennis. It's a very, very thin shell, and it's a sphere. And we can look up the moment of inertia of a thin spherical shell in the book, and it's 1/3 times 2/3. It's 2/3 times mr squared. This is the mass, and this is the radius. To be able to do the calculation, the only thing we have to do is take the mass and the radius and put them in the usual units that we need to use for problems like this. Not millimeters, but meters, not grams, but kilograms. The mass is 2.7 grams. Rewriting that as kilograms, that's 0.0027 kilograms. The radius, that's 1/2 the diameter, is 20 millimeters, but putting that in meters, that's 0.020 meters. We have the radius and the mass in the correct units. We have the formula for the moment of inertia. And so our solution is rather straightforward. We just compute the moment of inertia. It's 2 times 2/3 times m times r squared. We know the mass, we know the radius, we put those numbers in, and we calculate a moment of inertia of 7.2 times 10 to the negative 7th kilograms times meters squared, to two significant figures. Our assessment is this. We said at the start of the problem that we expected the moment of inertia to be very, very tiny. In fact, we got a number that was quite small. And so our final assessment is that our answer reflects our understanding of the way the world works.